we now discuss the solution of a problem from the section Integral Calculus. The problem is related to the area of a given region. This question has appeared in the Joint Entrance Examination Main held on 28th June 2022 in the first shift. The given question is the area of the region given by S is equal to the set of all ordered pairs x comma y such that y square less than or equal to 8x, y greater than or equal to root 2x, and x greater than or equal to 1 bracket close is, we are given four options. Option A, B, C, D. So, we are given a region S defined like this and required to find the area of this region. We now discuss the solution of the problem in detail. We are given the region S given by the set of all ordered pairs x comma y such that y square less than or equal to 8x, comma, y greater than or equal to root 2x, x greater than or equal to 1. Let's see what are these. Y square less than or equal to 8x is the interior of the parabola. It is a parabola opening rightward, and y greater than or equal to root 2x. It is a straight line passing through the origin. Right, and x greater than or equal to 1, it is the portion that lie to the right of the straight line x is equal to 1. The common portion for these three is the region S. Required to find the area of the region S. Now let us first of all take the parabola y square is equal to 8x and the straight line y is equal to root 2x and find out what are the points of intersection. So we take y square is equal to 8x and y is equal to root 2x. We have taken squared on both sides. We get y square is equal to 2x square. Equating, we get 8x is equal to 2x square. Then we will get a 2x times 2x multiplied by x minus 4 will give you x is equal to 0 and 4. The corresponding y values. So you go to the straight line, y is equal to root 2x. When x is equal to 0, y is also 0. That means it passes through the origin. When x is equal to 4, it is 4 root 2. So that means the points of intersection are the origin and 4 comma 4 root 2. Let's look at the diagram. X-axis, y-axis. The red one is your parabola opening rightwards. Y is equal to root 2x is the straight line passing through the origin, the blue one. The parabola is shown in the red one. In the points of intersection we have already seen it is the origin and the other point of intersection is 4 comma 4 root 2. And it is further given x greater than or equal to 1. That means you take the line x is equal to 1 and take the portion the right of the straight line x is equal to 1. X is equal to 1 will be here and right of that. The common portion is the region S. Thus, the region S is bounded by y square is equal to 8x, that is the parabola, y is equal to root 2x, that is a straight line, and x greater than or equal to 1. X greater than or equal to 1 means you have to take that portion which lies to the right of the straight line x is equal to 1. That means it is S is bounded above by y square is equal to 8x, below by y is equal to root 2x, the straight line, and x is equal to 1 on the left, look at the figure, and it moves to the right of this line, and when you are going, it will take x is equal to 4. That much is necessary for us. And what is the region? What is the region? The region is common to these three. So the region is now shown by vertical strips. The vertical strips are coming out. The totality of all these vertical strips, that is the portion, that is the area what we are asked to find. Agreed. So the area of the region S is given by, now these are now integrated by means of the vertical strips. Vertical strips are given y dx, integral y dx. So for that, integral y of the upper curve is parabola. We have said y of the parabola minus y of the lower curve. The lower curve is straight line, that we said is y of L. So integral yp minus yl to be integrated with respect to x, and from x is equal to 1 to x is equal to 4, then you will get this portion. So what is yp? Y square is equal to 8x, that is the parabola's equation, and y will be square root of 8x, that will be yp. And yl is already root x. So it will be integral x is equal to 1 to 4 in brackets under the square root of 8x minus square root of 2 multiplied by x dx. And now we will integrate and we will get the area of the region S. That we will do in the next slide. That's what we have. The area of the region S is integral x is equal to 1 to 4 under the square root of 8x minus root 2 multiplied by x dx. Integration is very, very simple. So root 8x will be root 8 into root x. Root 8 is 2 root 2 and root 2 is taken common. So root 2 integral x is equal to 1 to 4 in brackets 2 root x minus root 2 x. Root 2 we have already taken, so minus x. So integrate. So this is root 2 times integral of root x. Integral of x to the power of 1 by 2. That is x to the power of 1 by 2 plus 1 by 1 by 2 plus 1. That is x to the power of 3 by 2 by 3 by 2. To be evaluated between the limits x is equal to 1 to 4. Minus integral of x is x square by 2 to be evaluated between the limits x is equal to 1 to 4. That is equal to root 2 times, and 2 by 3 by 2, that will be 2 by 3 multiplied by 2, that is 4 by 3. And x to the power of 3 by 2, when x is 4 to the power of 3 by 2 minus the lower limit 1 minus 1 by 2 integral of x square to be evaluated at 4, that is 4 square, minus to be evaluated at lower end, that is 1 square 1. So 4 to the power of 3 by 2 is 2. 4 to the power of 4 means 2 square. 2 square to the power of 3 by 2 means 2 cube, that is 8. 8 minus 1, 7. 7 4s are 28 by 3. And here 4 square means 16 minus 1, 15. Minus 15 by 2, that is root 2 into 28 by 3 minus 15 by 2. Taken the LCM and simplified, we get 11 root 2 by 6. That is the area of the region S. So let's look at our options. Our answer 11 root 2 by 6 for the area of the region S appears against option B. Therefore, the answer for this question is option B. That is the detailed discussion of the solution of a problem which is related to the area of the given region from the integral calculus. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.